Priya, we have been discussing so far about the preparation of alcohols, phenols, and ethers. Particularly, we have discussed about the preparation of alcohols. So, if you've got any doubts from the in-text questions or the questions given in your book, you can ask me.
Well, out in 7.4 and 3.5, index
In-text question. Okay. So, can you read that question?
7.4.
7.4. Yeah.
Show how are the following alcohols are prepared by the reaction of suitable Grignard reagent or methanol.
Okay. So, in fact, that is when I was discussing about the Grignard reagent, the synthetic uses of Grignard reagent, where we have discussed about the molecular formula or general formula of Grignard reagent. We call it the Grignard reagent, GR, that is RMGX, is it not? So this R can be an alkyl group. So when it is an alkyl group, it can be an alkyl group or substituted alkyl group or anything. For example, you can start from CH3, methyl group, CH3, CH2, ethyl group, and so likewise it can be of any alkyl group. And it can be isopropyl group also. For example, CH3, CH, and CH3. Okay, so likewise, so the R can be substituted with the variety of alkyl groups like this. Do you understand? And similarly, the X can be replaced by the halogen compounds, mainly bromine, iodine, chlorine, etc. Okay. So in most of the cases, you'll be coming across this bromine and iodine as far as a Grignard synthesis is concerned. And you should know the general mechanism of this Grignard synthesis of the preparation of alcohol, about which we already discussed, but let me recap quickly. So the starting compound is very important in this case. For example, when you take aldehyde, particularly formaldehyde, this is nothing but methanol, is it not? So when this methanol, I'm writing the general formula. I mean, in terms of general formula. So RMG, we can put X. Okay. Now what happens is you've got this C double bond O. I already told you that these carbonyl compounds are very reactive. And there will be a pi electron transfer like this because of the difference in electronegativity. So among these two, for example, what are the participating elements here? Carbon and oxygen. So in these two, which is more electronegative? Oxygen is more electronegative. So what do you mean by electronegativity? Electron withdrawing tendency. So this pi electrons. So in double bond, you have sigma bond and pi bond. So these pi electrons are very soft and get be transferred to the oxygen by electron transfer, by electron transfer. Okay. So it becomes what partially minus because oxygen is more electronegative and this carbon becomes partially positive. Similarly, being electropositive, metals are electropositive generally. So they attain the plus and here are minus. Now what occurs here is this MgX, that is the partially positive charge, can attack the oxygen and the partially negative charge can attack where the positive, that is carbonium ion here. Okay, so that results. Now you can put H, C, H. Now since the pi electron is transferred, you put one bond and here the R is attacking the carbon. So R goes here. And what about the rest? This becomes O and then MgS. So this followed by hydrolysis. Okay. So what happens? That is HOH. It is cleaving the oxy linkage here so that you are able to get H, C, R, H, and then OH. And this becomes MgXOH. So this is the general mechanism. And based on that, you are able to get RCH2OH. This is nothing but RCH2OH, right? So this is primary alcohol. So based on the substitution in Grignard reagent, you are able to get different types of alcohols. For example, if you take, we will have a tabulation like this. Let me put that is instead of, I'm not going to change this one. Instead, I'm changing only R. Okay. So let us have H, C double bond O H. Now it is going to react with CH3 NGX. What I told you, this CH3 will transfer here, will go and attack carbon, okay? And there will be a pi electron transfer, and this is plus, so this is minus, this is plus. So this will go and occupy here. Similarly, so that you are able to get what? That is C, H, H, and followed by hydrolysis, it becomes OH. Okay, we can put followed by hydrolysis also. Okay, so that you are getting CH3, CH2, OH, which is nothing but ethanol, the primary alcohol. Got it? Primary alcohol. Now, listen to me very carefully. I am going to change this CH3. Instead, let me put CH3, CH2, MgX. You just follow the track. That is, what about the substitution attached to MgX can be reflected in the alcohol. So what is this alkyl group? Here it is ethyl. So what could be the product? You will get CH3, CH2, and then CHHOH. So what could be the alcohol? 1, 2, 3. That is propanol. This is also primary alcohol, right? Okay. Now let me do one thing. I am putting here cyclohexane. Okay. So cyclohexane. So instead of the CH3, CH2, let me put cyclohexane like this. Okay. And then MgX. Right. Now, what will you get? See, this should be coming in place of C. So C, H, H, OH. And here we can put cyclohexane. That's all. Okay. So this is cyclohexane based what? Alcohol. So this is ethanol, methanol. So cyclohexyl methanol. Okay. Likewise, you can build up. In this case, that is in that case, you write down the structures here. They have told you to develop CH3, CH, CH2OH, CH3. Okay. Now, based on this mechanism, what is the question asked here? CH3, CH, CH2, OH, and this is CH3. So this is the root from HCHO. There is no doubt about that. Okay. And what about this? This should have been attached to the R in the RNGX. Are you able to follow? So that is the clue. So based on that, can you do? Try. Put double bond O. Let's see H double bond O. Yeah, instead of or you are writing the entire isopropyl group. Is that not CH3, CH? What is that? Don't leave that one. That is from, you round that one. Round CH2OH, round CH2OH, that one. In the given compound. In the given compound, yeah. That is from HCHO, is it not? That is from HCHO. So what is the remaining? That should have been attached to RMCX. Okay, so you must be able to identify the R. Based on that, you can easily get the compound. Okay, so got it now? Very good. So split this into cation and anion, that is partially positive and negative charge. Show that, no, don't break it. Show that pi electron transfer. Show the pi electron transfer towards oxygen. So thereby it becomes delta minus and that one carbon becomes delta plus. And connect it. And what about MgX? That attaches to oxygen.
Sure.
Yeah, you have to show. That finished?
So the
Um, okay. Now what you are supposed to do? No, that is CH2OMgX, is it not? CHOMgX. You just follow the.
bond O.
No, that is your. Show me that. That is broken. MgX is joining through O.
So I should.
Don't put CH3 immediately. You follow like this. Now let me write. You start from CH3, CH, HC, double bond OH. This is the formaldehyde. Now pi electron transfer takes place. And instead of R, you are writing CH3, CH, CH3, NgBr. Okay, now delta plus, delta minus, delta minus, delta plus. So the entire group goes here and attack. And the MgBr comes here with oxygen and attack O partially minus. So rewrite like this H, C, and then H and O, and here through CH. Okay, and you have got CH3, CH3. Do you understand this? Now you are able to get MgBr. So on hydrolysis, it becomes MgBrOH, and the rest is, you can write this one, CH, CH3, CH3. Okay, we have finished. And this is nothing but CH2. Is it not? And this is OH. That's all. So which is nothing but 1, 2, 3, 4. That is isobutyl alcohol. But it is secondary, primary alcohol only because C is 2OH. So what is IUPAC name? 1, 2, 3. Propanol. 1 propanol. 2 methyl. 1 propanol. Got it? Okay. So follow strictly the mechanism. Do not change the point of attachment, right? Got it? Okay. Right. Done. Now you can erase, go to the next one. Now, what are you going to do with the second one? CH2OH. You know very well CH2OH, you take like this. So it is already given as a clue. It is obtained from methanol and the Grignard reagent. So the compound given here is cyclohexane based one. Is it not? So CH2OH. So immediately what you can do, that is CH2OH is from alcohol. I mean aldehyde. It's CHO. Okay. This is methanol. And this must have been attached to RMGX. So this is the R of MGX. Okay. So now you have identified cyclohexane is the alkyl group here. Cyclohexyl group is the alkyl group. So what you can do, you can take up HCHO as usual, double bond O plus Instead of or, you can put cyclohexane, right? Then MgBr, breaking. Yeah. So always put it in this direction. So it will be comfortable for you also. Okay. So MgBr. Now this is delta minus, delta plus. So delta minus will come and attack here. Delta plus will come and attack delta minus, so that you are able to get HC, H single bond and O, then MgBr, right? And what about this? Cyclohexane ring. That's all. Okay. So that you are able to get on hydrolysis, you are getting the cyclohexane ring followed by CH2OH. That's all. Plus MgBr and OH. Got it? Okay. Is it clear now?
Yes.
So first thing is you should be able to identify which compound has been given. Based on that, you can arrive at. Shall I give you one more problem similar to this?
Yes.
Right, try this. So in fact, you can put a table also comfortably, put like this. We are starting from the starting compound is here. You can put the starting compound right down. You can erase the entire book. Here the starting compound and put a table.
Hmm.
You can put a 3-column table, and this is the orange years Grignard reagent. Okay, by changing that, what will you get? The product. Okay, now let me write. I am taking H C double bond O H. This is methanol, and I am taking RNGX where R is replaced by CH3NGX, right? So I'm putting down that is nothing but R. So definitely this becomes CH2OH. This becomes CH2OH. That you know very well. Okay. And what could be this product CH3? That's all. Okay. So quickly it can be used as a ready reckoning. Got it? So when you use methanol as a starting compound and by using methyl magnesium bromide, you are able to get
Ethanol.
ethanol. One carbon is increased. Okay. So similarly, now let us see. We are used we are used the same methanol, but changing this into isopropyl, right? Okay. So NGX. Now rounded. You know very well this is going to attach here as CH2OH. So you can put CH3. So this is a very easy way. CH2OH. You know very well CH2OH is always obtained from formaldehyde. Okay, so this is the way you can easily crack any code. And similarly, let me take the third one here. Starting compound HC double bond O H. Now they are given cyclohexane, right? So NGX. So that you are able to get this cyclohexane and then CH2OH. That's all. Okay. Is that clear? Now what I'm going to do is I'm going to change this as acetaldehyde. So I'm just changing This I'm retaining the same, but changing the starting compound. So shall we put acetaldehyde? Can you do? Take the acetaldehyde, starter, RNGX, and you should be able to get the product. Now, okay, the starter is acetaldehyde, CH3, C double bond O, H. Okay, and what is the RNGX? Let's we put CH3 MgP. You know very well this CH3, the CH3 will attack here. Okay, and MgBr will attack O, and that becomes OH. So you are able to get what? CH3, CH, and then put the CH3 will come here. Okay, so that you are able to get secondary alcohol. Okay, got it? Now let me proceed with the tertiary also. For tertiary, I can take up acetone, is the starting compound. So CH3, C double bond O, CH3. So here, let me put CH3 and GBr once again. Okay. Then you can have CH3 will come and attack here. So CH3, C, CH3, CH3. O becomes single bond OH. That's all. So tertiary alcohols. Okay. Now I will ask one simple question. This is secondary alcohol. Let me build up. Okay. And you have to tell me secondary alcohol. I have got the secondary alcohol here, but it's a different types of secondary alcohol. Let me put like this. CH3, C, H. Here, let me put uh, CH2, CH3. And this is the alcohol. What is this alcohol? This is secondary alcohol. 1, 2, 3, 4. 4 means what? Butanol. 2-butanol. That's all. Right? Now, what could be the source compounds or starting compound? And identify the Grignard reagent. You know very well. See, we already know CH3. It should have come from CH3, CHO. Okay. So the starting compound is CH3, CHO being secondary alcohol, right? And the CH3, CH2 should have been rooted from Grignard reagent, that is from RNGS. Can you establish this reaction? You can erase the icon. Yeah, you can erase this. You can. Now that will be confusing. So this you can once again explain to others also. Please do that. Explain.
Starting compound is methanol. Using that methanol, we are adding RMGX. So you get the product CH3, CH2OH.
So where R is nothing but CH3. Around that R, around that R. That is CH3. So by replacing the R, different R, you are able to get different products. Okay. And the next one?
Likewise, same starting compound like methanol. We are adding CH3 isopropyl.
Isopropyl is the alkyl group. Around that one. So that should be attached to the C. That's all. So that you are able to get butanol. Okay, that is what butanol? Isobutyl alcohol. Okay, which is the primary alcohol only because CH2OH. And proceed with the next one.
So likewise, the methanol plus so benzene is alkyl, hexane is alkyl.
Cyclohexane.
Cyclohexane is alkyl group. So we'll get the product hexyl alcohol.
Correct. Cyclohexyl
Alcohol. This is also primary alcohol.
Yeah. That is methanol and cyclohexyl methanol. Then,
so we are changing the starting compound to acetone.
Now let me ask you one simple question. I want to get benzyl alcohol. Can you get?
Benzyl.
What is benzyl alcohol?
C6H6.
H5.
C6H5.
CH2OH. Okay. Now, no. Based on this third reaction, we just put phenyl magnesium halide. That's all. Put benzene compound.
Instead of
Phenyl. Put alternative double bond. Don't erase. Okay. So that becomes what now? Phenyl magnesium halide. From this, you are able to get benzyl alcohol. Okay. So you know that technique also. Clear? So this can be effective, and that is why Grignard is supposed to be the one of the best synthetic reagent. It's a very good organic synthetic reagent. Okay. Then by changing the starting compound from formaldehyde to acetaldehyde, you are able to get secondary alcohol. So what is the starting compound for the preparation or synthesis of alcohol using alkyl magnesium halide? Starting compound is formaldehyde. And what is the starting compound for preparing secondary alcohol? Oh, that's all. Explain.
So this alkyl CH3CH CH3OH will get secondary alcohol.
Is it clear now? Next. Now we can get tertiary alcohol also. How? Starting compound is varied. That is acetone.
Acetone.
Okay.
So here CH3 is alkyl group. It's tertiary alcohol is
Very
recorded.
Got it?
Yes, sir.
Right. So similarly, I asked you one more question. What is that question? That is, you are supposed to
Good.
get secondary butyl alcohol based on this. Right.
And then
There is.
we use
Hmm. So, see, you write this CH3, CH2, CCH3.
we need to form this compound.
Yeah, we had to form. Write down secondary butyl alcohol. Okay, so we need to establish the reactants using Grignard reagent and suitable starting compound. So you first of all you have to check whether it is primary alcohol or secondary alcohol or tertiary alcohol. What is that alcohol?
Sir.
Is it tertiary?
Secondary.
Identify CHOH, put round mark. So this is secondary. So secondary means the starting compound is very good. Put acetaldehyde, CH3, C double bond OH. This is the starting compound. Plus the remaining CH2, CH3 should be that you can mark it. CH2, CH3 mark it. That should be from CH2 may top. That should have been derived from Grignard reagent. So ethyl alkyl group is ethyl here. Okay. So this is the way you must obtain that strategy. So show the pi electron transfer neatly. Very good. Delta minus, put immediately delta minus delta plus. And Mg delta plus. So there is a difference between these two types of marking. In double bond, you are shown one single arrow that represents the pi electron transfer. Still the bond is there as a C single bond O. You are breaking only pi bond. Okay. But in this case, CH3, CH2, MgX, touch on the bond, where you are cleaving the bond, the entire, and that is why you are marking like this. Okay, so there is a meaning. Right, proceed. No, you must always attach a CH2 first, followed by CH3. Otherwise, it will land up in problem. You can adjust the position CH2 first, followed by CH3. CH3, CH2. The point of attachment is CH2 only. Put CH3. Show the hydrolysis. Break the bond. Put H and OH. You can write at the bottom. Okay, MgOH, MgOH on one side and Br on the other side. Okay, got it? That's all. And shall we replace simultaneously? We will start from acetone. Put acetone. No, no, no. You can include a CH3 there. Instead of H, put CH3 there. Now this becomes acetone, is it not? And come here. You can change here CH3, is it not? And you can change here CH3. Now it becomes tertiary alcohol. Got it? Okay. So if it is primary alcohol, what is the starting compound? Formaldehyde. If it is the secondary alcohol, acetaldehyde. If it is tertiary alcohol, that's all. Okay. Right. Now let us proceed with the next step. Here.
Write the structures of the product to following reactions.
Okay.
We need to write the product for this.
CH3, CH, double bond, CH2. These are all questions based on
To form alcohol.
alcohol, preparation of alcohol. What are the methods of preparation of alcohol? I think we have already done that sketch note. Can you draw that sketch note so that it should be useful to the students? I have divided into two major groups. Is it not?
Yes.
You can refer to that. So you can broadly classify into two, three actually. One is from alkene, is it not? Take that notes. Alcohol, put alcohol. Give it to her. Three actually. Alcohol, put round mark. Put a round, draw a round. So divide into three. One, two, three. So one is obtained from alkane. Okay. So if you know such type of clock diagram for preparation properties, it will be very easy for you to remember. And what is the second one? Carbonyl compounds. From carbonyl compounds, you can reduce it. Is it not? What is the third method? From Grignard synthesis. Okay, from Grignard reagent, you can use from RMGX also. Grignard synthetic group. So this we have put point number 1, 2, 3. 1, 2, 3. So we have discussed in detail about RMGX. Okay, right. So put a tick mark that we have done it. And these two we already finished. In the alkenes, what are the, from alkenes, how you can get by hydration? By hydration, then by can refer and tell. Write down all the possibilities. Oh, branch it properly. That is one technique. Another? Hydroboration. Yes. And the third one?
B. Methylation and methylation.
And how do you get alcohols from carbonyl compounds?
By reducing
Reduction.
on
Simply put, reduction. So reduction, aldehydes are reduced to primary alcohol. Ketones are reduced to secondary alcohol. That's all. Okay. You can put reduction. Reduction. Where you can put by reduction aldehyde to alcohol, primary alcohol. Write on that one. That one also. RCHO. RCHO gives RCH2OH, that is primary. RCHO, right? Wherever you like. Or CHO gives, put reduction. How to represent the reduction symbol? H within bracket. RCH2OH, that is primary. Put primary 1 degree. 1 degree. And from RCOR, ketone, you are able to get or CH or OH or CH down or then now you must extend the bond from carbon or then OH. This is secondary. Go put OH. OH where you put CHOH. Yes. So that is secondary. Write down secondary. That's all. So we have brought everything under one page. Now, this is the concept, that is that double bond is going to be, you can write down here. You can put the scheme here. Put CC double bond. No, no, no. You put on the right side. Just write down C double bond C. Okay. Where HOH is going to be added. Plus, put plus. Write like this. C double bond C and H then OH. This is the scheme. Okay. So this bond will come here, this bond will go here, so that you are able to get, see that, C, OH, that's all. This is the scheme, okay? Write down. Show like this. You write like this. Okay. Double bond, pi transfer, pi. No, you write C below which H, C below which OH, so that you can comfortably show the diagram very clearly. H is going to be attached here. OH is going to be attached here. That's all. This gives primary alcohol. Right on the next step. Primary. Now, whether it is primary or secondary, that is going to be decided based on the nature of the alkene. Correct? whether it is primary or secondary, that is going to be decided based on the alkene. If it is symmetric alkene, leads to primary. If it is unsymmetric, it adopts which rule?
Markov.
Okay. So in that case, you will get secondary. So that is the logic. Okay. So can you get, based on this, can you get secondary? Assuming that it is, now we have shown the symmetric alkene. Now let me write the unsymmetric alkene. Just note down this. Rewrite unsymmetric alkene. Let me put like this. This is unsymmetric alkene. Now I'm not showing any hydrogen here. Okay. So this hydration is going to take place. So in that case, the negative part of the addendum is OH minus. So this will go and attack here. Are you able to follow? So naturally this will come here. So it means what? C, OH at the center, and this becomes C, then H. So if you want to put, you can put. Okay, that's all. Now it becomes secondary. So based on the nature of the alkene, if it is unsymmetric, you will get secondary alcohol. If it is symmetric, you will get primary alcohol. That's all. Okay. So this is the scheme for these for such type of reactions. Now can you proceed with the answers? Yes. Right. You can guess. Why you put OH on the center? Unsymmetric alkene. What do you mean by unsymmetric alkene? The double bond is not evenly distributed. It is on one side. In case of symmetric alcohol, it is centrally positioned. Okay, right. That's all. Next. And you must be able to identify where the double bond or keto group is present. So where is the keto group present here? So in the first case, we were, and what type of preparation of alcohol is that first one? That is based on hydration, the first scheme. Okay, please touch that hydration. So the first reaction is based on that mechanism. Okay, listen to me. And what is the second scheme? Yeah, that is the second one. So you can round that double bond O. But there will be a confusion for you. There are two double bond O. Which should be taken? The ketone should be taken. So identify the ketone here. So rounding. Okay, so simply by attacking that one, you can easily get it. You know very well from ketone, what type of alcohol is obtained? Second one. That's all. So put OH, that's all. Very good. Now, shall we try naming this compound? Okay. Right. Now, before that, I would like to explain another important because first of all, you tell me what are the function group present. So when you are, see, whenever you want to coin the compound, that is name the compound by IUPAC, you should be able to analyze that compound. First of all, identify the major, that is skeleton, that is the main hydrocarbon, and function group, then side chain, etc. Okay. Now let me clearly tell you. Please follow me. You can write it on the. Yeah, you can write here. Now listen. So I am taking here. Let me take that compound. You just follow how I am identifying the function group and the parental hydrocarbon. See, when I teach you, you must listen to me. Now listen. So let us identify. Sushmita, tell me which are the function group present here. Ketone. Where is ketone? Double bond CW. So this is ketone. Write down. You can also do. This is ketone part. And any other function group? Yes, sir. Ether. Ether. Hmm? Ether. It is not ether. It is joined into, you have got the carboxylate functionality here. Okay? Okay. This is the carboxylate group. Okay? RCOO minus carboxylate group. And since CH3, this is R. So it means it is an ester. So RCOO R is an ester. First, let us try to find out the or name the esters. Esters are obtained from RCOOH, that is acid, plus alcohol. Let me reverse like this. Okay, so that you are able to get water is removed. The remaining is RCOO all. When you write this ester, you should write like this R C or C double bond O R. Got it? And the point of attachment of this C double bond O with the R is very, very important. That decides the nomenclature, right? So how it should be, for example, this is the attached group and this is the main group. This is carboxylate. Okay. So you have to name this as methyl carboxylate. Are you able to follow? So what is this? This is RCOO minus. You must name this compound as carboxylate. Okay. So carboxylate means alkanovate. What is that? Alkanovate. And this is the respective alkyl. So alkyl alkanovate. Now replace this. Let me put CH3, C double bond O, O, CH3. What is this compound? This is alkyl group, that is methyl group, right? And what about this alkanovate group? What alkanovate? 1, 2, ethyl, ethanovate. So methyl ethanovate. Got this point? What do you call it? Methyl ethanol. So you have to name like this one, right? So if it is a methyl ethanol, and by common name it's called, this is acetate. So methyl acetate is also called methyl acetate. So remember this. Okay. Now let us come here. So what is that? You have the methyl group and this is 1, 2 ethanol. So methyl ethanol. Got it? What is that? Methyl ethanol. And hide this. What is this compound? Cyclohexyl, right? So this is cyclohexyl, then ethanol, where methyl group is there. So methyl cyclohexyl ethanol. Got it? And in this second hexyl, cyclohexyl, this is the first one and this is the second one. In the second position, you have got oxo. So it should be called methyl within brackets 2-oxo, correct? Right, 2-oxo, and then cyclohexyl within bracket, then ethanol. Do you understand this? Why I have put this, that is within double bracket? Because two hyphen, put two hyphen, two hyphen. So 2-oxo cyclohexyl. So this should be named like this. So what is this? 2-oxo, okay, cyclohexyl group, okay, and this is ethanol group, and this is methyl. So first comes methyl and followed by this. And that is why you put within bracket. I hope now you should be able to understand. Now how to name this compound? Methyl within bracket 2-oxo cyclohexyl and then ethanoate. So this is ethanoate. Okay. So similarly, you can name the other compound also, the product also. Can you give the product here? Hmm. Product. Yeah. Now you can identify, that's all. Instead of oxo, you are able to get hydroxy. Identify like this, whatever I done. Put the ethanoate. First identify ethanoate. That's it. Write as ethanoate. Write as ethanoate. And you got one substitution on the right side. That is methyl substitution. Put round mark. Put methyl. Okay. Now listen to me. Listen to me. If there is no cyclohexane, you will call it methyl ethanoate. Correct? Now, in between that, you have got that one. That is why you put in between and put the bracket also. And what is that cyclohexane? It is not a simple cyclohexane. It is 2-hydroxy. Why it is 2-hydroxy? Because the point of attachment is 2 here. So put round mark. No, 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 for the entire cyclohexane. So 2-hydroxy, put 2-hydroxy cyclohexyl. Is it clear? Now you can join all these names together. So hexyl, hydroxyhexyl. So now join everything. So methyl 2-hydroxy cyclohexyl ethanoate. That's all. Is it clear now? Right. Ethanoate. Hydroxy, hexyl, then ethanoate. Okay, good. And now let us proceed to the third one. So in the second case, we adopted the second mechanism. Okay, that is, it is a rooted from, yeah, carbonyl compound. Okay, and the next one. And what is the suitable reducing agent? That NABH4. Okay, right. Next one. Ah, aldehyde means what? Round the aldehyde, you will get, that's all, CH2OH. Hmm. Okay, so here also you are adopting the second type of preparation. Okay, so can you, Emily, can you come and summarize the entire sketch note? That one, that one. Hmm.
Preparation of alcohols. It can be done three ways. And the first subdivision is from alkenes. And in that, we can follow either hydration, hydroboration, that is BH3, by mercuration and demercuration. And the second one is carbonyl compounds. Reduction of carbonyl compounds. First one is we can reduce aldehyde RCHO into primary alcohols, the RCH2OH, by reduction. And the second one is RCOR, that is by reducing ketones, we can obtain secondary alcohol.
Can you cite an example for these two? Yes, the same one. For the second one, you have got the ketone. So from ketone, you are able to get secondary alcohol. And then,
For the first one, we have done,
so here the first one,
we have going to
primary alcohol. Why? It is from aldehyde.
aldehyde.
Okay, right. And the third one?
Third one is Grignard reagent.
So what are the three types of alcohols? Primary.
Secondary.
What is the starting compound for primary alcohol?
Formaldehyde.
Formaldehyde. Secondary alcohol? Acetaldehyde. tertiary alcohol, acetone. Okay, so based on that, we can easily prepare the three types of alcohols. Okay, good.